Welcome everyone to the MLOps Live series, the webinar series where we explore what it really takes to bring data science into production and drive real business impact with AI. I'm Edith, I'm the head of marketing at Iguazio, an AI startup acquired by McKinsey back in 2023. And I am thrilled to have you here with us today. We have a great session ahead of us. Today's topic is From Models to Meaning, demonstrating AI value in production with open source tooling. And we're joined by two fantastic speakers. Joseph Perkins, Principal Product Manager at QuantumBlack AI by McKinsey, and Gilad Shaham, Principal Product Manager at Iguazio, a McKinsey company. And today, specifically, we're going to explore how open source tools like MLRun and Vizro work together to turn AI use cases into production-ready applications. We'll show you how to orchestrate and deploy models with MLRun while using Vizro to bring real-time visibility and business context to the results. But before we jump in, a few housekeeping items. This session will be recorded. You'll receive the link afterwards, don't you worry. And also, please feel free to submit your questions at any time in the Q&A tab on the bottom of your screen. We will answer as many as we can during the live Q&A part. It's always a highlight. We've added 2 short polls today, and your input will really help us shape future sessions, and we really value your feedback. So please do take the time to answer those. And finally, you're invited to join our MLOps Live community to continue the discussion or ask us questions afterwards. We'll share the link in the chat in a moment. So I don't want to take up too much time. I want to let our fantastic speakers get started. So without further ado, I'm going to hand it over to you, Joe.
Thank you very much. Let me just share my screen. Hello, everyone. Hopefully you can see the presentation. So at this point, I'm just going to give a kind of a brief overview of the problem space that Gilad and I will be talking about, specifically in terms of demonstrating AI value in production with open source tooling. And then we'll go into some technical demos. We'll be talking about one solution involving MLRun and Vizro. And for context, MLRun is an open source MLOps platform for machine learning applications created and maintained by Iguazio, which is part of McKinsey. And Vizro is an open source Python-based visualization tool created and maintained by QuantumBlack, which is also part of McKinsey. So the continuing challenge that many people face is to achieve, obviously, business impact from complex AI applications in production environments. Before all the recent evolution in LLMs, the previous buzzword on people's lips seemed to be MLOps, because obviously traditional machine learning was already quite powerful by that point, but it was still surprisingly difficult to sustain value in production from machine learning deployments. So people were looking for ways to improve ML operations in production in order to provide lasting value. And with the arrival of LLMs, the buzzword on everyone's lips became Gen AI, and the focus and the hype was in the power they have and the potentially immense impact they promised. For example, when combining traditional machine learning like Bayesian models with new approaches like agents, which allowed new types of problems to be solved more effectively, very much like the call center operation that we'll see later. But also the increases in computation capabilities and the automation that was previously for very manual tasks that agents now allow us to automate, such as data cleaning. Those have increased the speed at which projects are ready for production deployment. But as the kind of initial hype around Gen AI starts to die down a bit, people are again realizing that they still face the original requirements to productionize things in order to generate lasting business impact. And now they just have even more complex requirements on top of what they already had before, things like monitoring LLMs in production and broader context management. And to put that in a bit of kind of numerical context, an article that was recently published by McKinsey in November pointed out that nearly 2/3 of respondents say that they've not been able to begin scaling AI across their enterprise yet. And only about 39% currently report meaningful impact at the enterprise level. So what's the cause of of that challenge in bringing AI to production? Well, part of that difficulty is due to deploying and running those solutions containing LLMs in production environments. This can be tricky as various new requirements have arisen for them specifically, such as how to control agentic processes alongside traditional machine learning pipelines within the same product. Plus, everyone's having to learn the new emerging paradigms to tackle those new requirements, which are themselves rapidly evolving all the time, such as how to ensure transparency and monitoring of LLM performance at scale. One of the second issues is that surfacing the value of projects to stakeholders early enough and well enough to get their buy-in for moving to production stage. This can be especially tricky if the stakeholder doesn't grasp the technical complexities of what's going on under the hood, or if they can't explicitly see the potential value that could be generated by that particular project. And a third issue is customizing and maintaining the LLM-produced output in production. I think probably all of us have seen examples of where it can be very difficult because vibe-coded output can sometimes immediately become legacy code the moment it's vibe-coded, especially if it's in a language which nobody in the product team understands. For example, if a JavaScript app has been vibe-coded and nobody on the team knows JavaScript well enough to modify or maintain it, which creates issues with people trusting the code well enough to be willing to deploy it in a production setting in the first place. So MLRun and Vizro together help offer one solution to this. Firstly, by being Python-based and Python workflow compatible, which democratizes the access because it means that existing team members can use it easily to develop and deploy and maintain solutions in production, since most data science and developer teams know sufficient level of Python. Secondly, integrating them together with each other for an end-to-end solution, which provides a production deployment framework in the form of MLRun for stability and a visualization tool in the form of Vizro for easily surfacing values to stakeholders in a way that works seamlessly from POC to production. And thirdly, being open source, which obviously means that it's free and can be deployed without many restrictions with a community for active support. And there are a few extra benefits of Vizro, which we'll cover in the demo section in a moment. And those help to structure vibe-coded output and make it easier to implement that also in production. So just very quickly to explain a bit more about the tools themselves and how they achieve these solutions before we dive into those demos. MLRun is an open source AI orchestration framework, including solutions for both traditional machine learning and generative AI applications. It works across the end-to-end data science pipeline, from data preparation and model optimization to pipeline deployment and monitoring. It supports both cloud and on-prem environments. And the advantages are that it enhances collaboration by providing one stack across the data engineers, data scientists, machine learning engineers, and other developers. And it provides end-to-end observability, data lineage, experiment tracking, and now for the new LLM requirements as well. Plus, it makes it easier to scale those across distributed processing. So given that it includes solutions for both traditional ML and generative AI, these capabilities all combine to make it a stable platform for deploying modern production AI and making it more sustainable to maintain and scale them in the long run. And on the other side, the Vizro tool is an open source Python-based data visualization tool. It allows developers to create complex dashboards and apps from mostly declarative configuration. It automatically implements inbuilt visual design and front-end engineering best practices. So any developer who knows simple Python can create complex dashboards with most of the front-end functionality you would expect from BI solutions from just a few lines of simple configuration. without even needing to have visual designers on board or front-end engineering expertise. Since it's built to incorporate Dash, it also allows custom React components to be plugged in easily, which effectively means that it can be customized almost infinitely. And crucially, in this world of Gen AI that we're living in now, it can be combined with things like skills to quickly vibe code an output, which is itself Python based, and so is much easier to understand and to maintain than other tools which produce JavaScript outputs. We'll discuss a bit more about that in the demo. So now within minutes or even seconds, you can create POC dashboards to surface those insights to stakeholders, all with a consistent look and feel across every dashboard you produce across the entire product, and then instantly deploy them to production because most of that code is already pre-validated within Vizro thanks to Pydantic. So it's much more production ready and easier to trust. So by combining both Vizro with MLRun, it allows all these advantages to fit seamlessly together into a stable production deployment foundation, which MLRun provides. So now that we've gone through a brief introduction to that problem space and the potential solutions, Gilad will share a specific example of how this all comes together in the case of a call center.
Yeah, thanks, Joe. So the background with the work that we've done with this client is that they wanted a call center analysis. Actually, it's a very common use case that happens with Gen AI, a very common scenario that customers using to improve the overall efficiency and business results of the call center because there's a lot of potential and benefits of using Gen AI. Specifically, there were several limitations or several challenges related to this engagement, including the fact that they were very concerned about privacy and security, and also everything ran on premise, so everything needs to be hosted on GPUs. They can't use things like OpenAI or any cloud services, which means that it's very important to think about efficiency in the deployment itself. And at the end of the day, they wanted to improve the service that they're providing to their own customers. This is a very, the business is growing and have more customers, and they need to automate as many things as possible. Also, as part of the call center, there's a real requirement to train the agents, train the representatives themselves, because they need to provide better support for the end customers. And a lot of this started when we used GPUs. Initially, it didn't scale, and a lot of the solution there was to actually offload some of the work to CPUs and combine things that we'll see later in another demo on how we combine CPU and GPU, or how we can build the pipeline. And at the end of the day, we want to be able to present this in a way that is useful for the end customer. So the end customer, the end user here is someone who is analyzing the calls after the fact and can learn about the individual behavior of the agent, something around the customers, if they were served correctly, and then create any analysis around that to further improve this. And we can see the results that they actually got based on this work. And now Joe will show the demo that we've done, and everything that you'll see here was built with Vizro, and it's very easy to deploy it as part of that whole pipeline that we've built with MLRun.
Cool. Thank you very much. So yeah, I can now briefly show an example of the Vizro output. This is pre-recorded video just to ensure it covers all the right things. This is a dashboard that was created as part of that implementation. Everything you see here is in Vizro. And the key thing about this dashboard is that it's surfacing the output, or the things that the data science models are predicting and monitoring within the context of the broader information that business users need to make decisions about what's going on. So this dashboard is intended for call center managers and people assessing the performance of the models. And some of the key metrics that they're looking for, things like upsell success and the percentage of concerns addressed. But that information is obviously presented in the broader context of things like time series, calls over time, geographical distributions, and so on. So this is obviously a typical BI dashboard that covers many things. And the functionality provided by Vizro is things like being able to change the theme, being able to show many different types of charts. It has all sorts of controls, parameters, interactions between things, layouts, navigations. As I mentioned before, you can effectively create any chart that you like in JavaScript if you want. The key thing here is that, again, it's all Python based. So this can be built by the actual developers themselves who are working on the project. They can be the ones to put in what
Good day. This is Laura Anderson from Iguazio Internet.
To convince their stakeholders that they're working with, and that they are able to modify it and develop the POC themselves, and then immediately deploy it into production. What I'll show you now is a little bit about the actual code of that. What does it look like under the hood? And we can get into some of the discussions around how that works in reality. So let me just share my my cursor screen. So hopefully you can see here the information that was used to build the application. You can vibe code it, as I'll show you in a moment. But on the left-hand side, you can see the configuration for Vizro. So let me just share the entire screen so you can see everything that's going on. Okay. So here you see the application on the left-hand side. All of the code that's been used is this simple configuration. If you take a look at the Vizro repository, you can see the crux of what's going on here is very simple configuration. Here you have kind of 20 lines of code, 25 lines of code that build a dashboard with controls and charts and so on. And as you can see, this is, although it's Python based, it's simple enough for even a less technical person to understand and edit. So someone else can come along if someone else inherits the projects later on. Once it's been deployed to production, they can easily make tweaks to this without needing to kind of go deep into the code or understand everything about Dash or Python and how it was constructed. That allows it obviously to survive longer in production. And they can either make kind of fairly large edits themselves through the configuration. But these days, obviously, there's Gen AI that's added an extra abstraction layer on top of what is already an abstraction layer of the configuration. So we'll show you briefly how that can be used in this case to edit the dashboard purely through using a prompt and an MCP server. So here's a pre-recorded example just to make sure it works. This is the dashboard that you saw with blue bubbles. You can just in a typical cursor environment implement a prompt to change the bubbles to be magenta, and within a few seconds it can figure out what needs to happen and make the change. In fact, these days I don't think it even needs the MCP server, because LLMs know enough about Vizro, since it's an open source tool. They can probably make these changes directly themselves, just a one-line change, and you can see it make changes to pink in the bubbles, magenta. Again, that is democratizing the access and the ability for the developers on the team to produce, externalize the value of what they're doing to the stakeholders. It doesn't have to be this type of application. It can be any application that's surfacing what's going on under the hood into something a stakeholder can understand. And I've learned not to underestimate the value of a good map when you're trying to get the buy-in from a senior stakeholder. That can be, in some cases, the difference between going to production and not, whether you actually get that buy-in at that point. But these days, just being able to do that in using an MCP server and an LLM is not as impressive as it was 6 months ago. We find now that although we have solved here the ability for developers to actually build dashboards and deploy them in Python in production, what is now an arising problem is the fact that they don't know what to put in the dashboard. In many cases, developers are not designers, and they don't necessarily even go through the process of identifying the end users or figuring out what they might need to see in a dashboard or any kind of visualization. And so we've kind of moved left in that process to create now a Vizro skill, which can help the developers work through that, again, without a designer and without any previous expertise in design. So here there's a kind of pre-recorded video. It's 12 minutes long, and it shows you an end-to-end process of going from an individual prompt to building an entire dashboard. So the prompt here is that we're asking it to build a dashboard about iron mining from a single prompt. And what it's doing is, this is Claude Code, so it's using the Vizro skill, which is open source, you can access it today, and guiding the user through the process. One of the good things that Claude Code does is kind of present these little questions to the user at different various points through the process to narrow down. So it's asking to be very specific about who the user is, who the end user, and then it can just ask questions about what types of metrics you have, what things you're trying to monitor. With that information, it can go ahead and start building the requirements for the dashboard. So I won't go through these in every single step, but you'll see once it has that, what it's starting to build on the left-hand side here is a specification. So as it's going through these individual steps, it's creating documents which end up being a specification for the output that it's going to build at the end. This is valuable because it is something that, again, can be used to refer back to later on. If this thing is in production, people can come back and understand what the reasoning was behind why things were on the screen. If they need to go back and make changes, they can make changes earlier on in that specification and have it flow through to kind of the implications and impact for the rest of the product. So it goes through various stages of that specification. Here it's creating a wireframe, like an ASCII wireframe, to allow the developer, again, to get a better understanding of what the end product's going to look like. They don't need to leave their Python workflow. They're still in their IDE. And it, again, continues to ask questions and to refine the thinking of the developer as they're going through to build this dashboard. This is before it's even started to write any line of code for what the actual dashboard is going to be and how it's going to be constructed. So it goes through all of these processes, creates a specification. You can see on the left-hand side, it's building up more files of specification in different formats until it gets to kind of the final specification that it's happy with. And then it starts to build the dashboard, which is the thing that kind of any MCP server could do now, or even Cursor itself directly. And here you see an example of the final dashboard as it's spun up. The really useful thing it does is also spins up a playwright front end. The playwright is something that allows you to see what allows the IDE or the LLM to see what the dashboard looks like. It can start then to do user acceptance testing on that dashboard. So here it's going through a few steps of user acceptance testing. All of this is fake data that it's come up with for the purpose of this. And then the developer has a dashboard which they can play around with and start to use, show to their stakeholders, get the early feedback, and hopefully get the buy-in from the stakeholders. And then, because this is already all in Vizro, which has validation inbuilt because everything is based on Python models, what they have at the end, although it took 12 minutes to build effectively a POC, this could be taken and deployed directly in production, and everything should be stable. Everything is tested thoroughly through the open source repository as the fundamental contents anyway. So yeah, there we have kind of the end-to-end process. That, again, the output of this is purely Python based, and therefore it's a lot easier to deploy in production and easier for people to maintain, because you don't need basically anyone on the team that knows Python can also be the person that maintains it. I think there'll be some time at the end for questions if it's useful, but in the immediate next steps, I think we'll hand over to Gilad, who will share another use case in the banking industry. But first, I think we'll have a quick poll, so I'll hand over to Edith.
Okay, so you should see on your screen right now the first poll. What is your biggest challenge in getting AI models into production? So I know that you may have many challenges, but if you can try to pinpoint, please, what your biggest one is. Here are a couple options for you to choose from. Lack of automation. Thank you, everyone who answered that poll. I'm going to close the poll right now, and I'm going to hand it over to you, Gilad.
Thank you. Yeah, so we'll see another demo that showcases a more elaborate scenario around MLRun, and we'll also see the visual dashboard that we have there. So the way that this works is that we want to have a banking agent that helps customers in some business scenarios, like they would like to ask how to open a checking account, saving accounts, and so forth. Rather than just creating a chatbot that I don't know goes to RAG and so things, we want to give it a little more intelligence. So the first part is actually using classical ML. These things still exist, and sometimes it makes more sense to build or use such models rather than using more expensive things like LLM, Gen AI, things running tokens with OpenAI or something that is local with GPUs, because these models work and are well established. So we have a pipeline that builds that model, and we're using that pipeline in order to build the input for the context for the agent itself. Before we actually call the agent, we have guardrails. These are real-time guardrails. We have two here, one for toxicity, and the other is for banking topic guardrails. So if I ask the chatbot something that is not related to banking, I would immediately get an answer, sorry, this is not related to banking. I can only answer questions that are related to banking itself. And then we go through an input analysis, which is the churn model, and also the sentiment analysis. So the agent's answer would be based on this context, on this input, because if the sentiment is negative or positive or neutral, then the LLM would craft the answer differently. And if the churn risk is high or low, that would also change the action. For example, if there's a high risk to churn, maybe go to a human operator rather than just continue the conversation with the chatbot. The chatbot itself obviously can use tools such as RAG and web search and everything. And one other thing that is important here, that everything is monitored. At the end, we'll see the benefit of having Vizro as part of this pipeline, because without it, normally what you would have is just HTML and results, HTTP and results that you would send a query and a response, which is good for testing, but it's very hard to convey what we have done here to end users and explain the value of this chatbot and how well it works. So let me just share the screen here. So we'll start with the MLRun UI, which you may have seen before in other webinars that we had, where I can see tracking of artifact workflows, monitoring applications. I can see different runs. I can see real-time functions. For example, this would be where the agent is actually running, where I have guardrails running in real-time monitoring, and also the visual dashboard. That's what we have done. We have created something that we call application runtime that can run any type of application. And Vizro is actually the first use case that we wanted to do because of the fact that we want to be able to host this dashboard that the user is running. Within the UI, I can go and see the different jobs. I can monitor the workflow. So for example, if I click here, I can see this is how the model was trained. So there is data and trained, and then it was deployed. I can see the different parameters. There's nothing Gen AI here, and these are all capabilities that exist for a long time, but we still need them in order to build these models and in order to work with these models. So soon we'll see how we combine this model with a Gen AI model. If I think about monitoring, I also have a guardrail. I can also monitor in production the actual guardrail itself. So let's say I deployed it and I would like to see whether the result fits into the answer is okay or not, and maybe someone is asking some tricky question that is not really related to banking, but it passes the filter. There's a monitoring LLM as a judge, which identifies this and gives this a score. So I can actually identify problems and change just a guardrail without changing the entire workflow and without changing the entire pipeline here, just to fix that part. And this is important, especially when we're thinking about production, to be able to monitor what's going on. And for the monitoring itself, you can pretty much use, just like we did here, LLM as a judge, or you can use any external type of monitoring. I won't go through much through these screens, but I think showing the demo itself would be more useful. So what we see here is pretty much in the README that you can also see in the GitHub repo, which we'll share. You can see that we're talking about the business use case where we have a chatbot and the model behavior changes according to the context. There was observability. You can see the technical capabilities that were highlighted here. Many of them are already mentioned around end-to-end pipeline, guardrail, LLM judge, going to use RAG, application serving graph, which we'll see how we build it here, the Vizro UI, and of course everything is monitored. This is the same architecture that we've already seen, and we'll see soon how the application UI works with Vizro UI. Everything else here we've already seen in terms of the dashboard, the pipeline, the workflow, and the monitoring. So first off is creating that churn model. So first thing, I create or get a project. This is the same project that we have seen the UI. Within that project, I'm going to create all the different functions and monitor all those artifacts that we have seen. I want to enable monitoring because I want to monitor these models. So I enable that as part of the project. And here, this is very standard today in terms of the ML pipeline. I get a data set. I run that workflow, which I've already configured to get the data, split the data to validate, train, test, train the model. If I'm happy, then deploy the model. And I can also see the results here of the run itself based on this tracking, check the outputs, check the scores. If I'm happy with everything here, I can say, okay, I passed this step, and now I have a model that I can use. Not necessarily that every time I have to build this model. Obviously, I can use an external model or build it as a separate project. But here we wanted to showcase that it's possible to certainly combine the two, even in the same project. Now, going to guardrails, we can see that I'm still in the same context of the same project. Here, we actually show that it's possible to work with OpenAI, which is very common to use an external service for LLM. But as we have seen in the previous case, there are some cases where you don't want to run something with remote. Maybe you don't want the data to go to the cloud. Maybe there are things around costs here. And we can also show that you can use the model. In this case, it's a very small CPU model, but it can also be a GPU-based model. And the idea here is that if I want to try things without incurring too much cost, I can do that before I go to external service, before I go to something like a GPU, which would cost more. Then I can just try something even locally. First thing is that I like to set up the LLM as a judge, which we have seen earlier. So it's important to think about this because you'll see that I'm creating LLM as a judge. I'm also creating that guardrail. LLM as a judge or the monitoring application doesn't work in real time. So it monitors whatever I wanted to monitor. In this case, we set in an interval of 10 minutes, and I can see those reports and improve it. The guardrail itself, which we're creating here and deploying here, this is happening in real time. So it has to answer whether it does pass the filter or doesn't pass the filter as part of that call when the user actually communicates with the chatbot and sends something. So these are two different use cases, and that's why you see two different deployments here. And it's important, and that distinction is very important here. So I deployed it, I can test it. I have several questions here that some are related to banking and some are not related to banking. I can run this test and I can see that what is a mortgage returned true and who painted the Mona Lisa returned a false answer. Obviously, I can do a more elaborate test case here as needed. And then I have the toxicity filter, which is less detailed because it's pretty much the same idea. We can monitor it, we can deploy it in the real-time function, and that's it. And the third part, this is where everything comes together, is actually the application deployment. As part of the demo, we created local milvus, which is just for the demo. Obviously, in most cases, you would have a real vector database somewhere that is being used, but it's just easier to set things up here. That's why we did it this way. And then I take the different functions. I have the different guardrails and the serving, which is the churn model. And now I'm going to build that banking agent. The nice thing here is that you can see in the code that I'm pretty much building the same steps that you have seen in the diagram, where I'm starting to build those guardrails, the different steps, and each step I'm saying what would happen. In this case, I want to have a choice, whether it is accept or reject, based if the answer is true or false. Now I'm going to build the context, so I have sentiment analysis and the churn model. And the step that builds the context actually puts it as part of the prompt that goes into the LLM, the agent itself. And you can see that in the prompt, we actually told it that if the churn propensity is high, then escalate to a human operator. Don't escalate if it's a low propensity. Obviously, we could have done something more complicated than this part, but it just shows how we can build this context as part of data that comes from different models. And here again, we can choose if we'd like to use a local model or something that is remote. And of course, I can choose which model I'm going to use, even if it's remote. A nice thing here is that I can also show the graph here, and I can see that it actually is defined the way I expected it to be, because sometimes I might make a slight error when I build this code. So first part, I want to test it locally, so I can test the entire graph locally. Obviously, if it's using OpenAI, it is going to have OpenAI calls, but if this is a local model, it's just going to run things locally on the notebook. And then I can do several tests. For example, something that is not related to banking. I can ask questions like, what is a mortgage? How to apply a checking account? See different results. So this is very standard practice if I have a model or I have a whole pipeline here that I want to test it. Let's say I'm happy with all the local tests, and you can see I can get something even more elaborate. I can even call a function that does all the tests, obviously. And you can see also in the full inputs that it's not just the output itself of the model. I can see the outputs of the guardrails and the different context input analysis that was created here, whether the sentiment analysis is neutral and the churn is high. Next, I'll deploy it. So I'm taking the same graph and deploying it. And now I can do the same tests. And without Vizro, what I have pretty much is this test. I can run this. I can even create a set of different questions and run it and see the different results and look at them. But at the end of the day, if I'm going to present it to someone who is less technical, if I want to present this work to a wider audience or to management, then there's a question of how to visualize it. And this is where Vizro comes in. It's very useful. So the way that it works is that we have here the Vizro dashboard. Obviously, the dashboard can be created the same way that Joe just showed, in terms of I can run it manually, I can create it with the Gen AI, and I'm just creating a TarGZ here, and I'm creating this artifact, very similar to how we've seen in the beginning that I have an artifact for data. Now I have an artifact for the code. And pretty much, again, I'm creating a function. In this case, it's an application, and I'm giving it the source, that archive as a source. I could have also given it an image. By the way, created a Docker image and deployed a Docker image. You can see that we're using G Unicorn. I'm giving it different parameters, and this is hosted by MLRun in the same cluster. So if I switch to the actual example of how this runs, I can print here how tall is the Eiffel Tower, for example. So obviously here you'll see that the banking engine said that it's a banking engine won't answer this question. Next step, I can ask a banking related question. For example, how do I open a checking account? I expect to answer something that is related to banking based on the data that we provided in the RAG. And we see here that it looks okay. Next, let's see what happens if I ask the same question, but I'm also going to say that I'm frustrated. So obviously this sentiment here will be negative compared to the neutral sentiment that we have had previously. So here we'll see that it acknowledges the frustration, but obviously I have here some information, but it doesn't, for example, suggest that I will go to human operator, just like the prompt that we had. You can see that in the parameters on the right-hand side, I have another user I'm simulating here. So in this case, Alice has a high churn propensity. Again, I'm going to ask exactly the same question of I'm frustrated, how do I open the account? And in this case, you'll see that I'm actually opening, I actually have the same kind of answer or similar answer. It acknowledges frustration, but it also points me to a human operator. And you can see that the sentiment here is negative. So in this 1 minute short session that I've just shown you this, it's much more effective than showing you a notebook and showing you different tests and showing the results and all of these things, which again, it's good for as I develop things and as I look for different things here, but it's not something that is as effective when I actually want to show something that is visual to the end user. And you can do both. You see how simple it is just to take a visual dashboard, build it, as Joe has shown us in his part, and how to deploy it. It's just creating another function, just like all the other functions in MLRun.
To launch the next poll. So we talked a little bit about challenges in the previous poll. Now, if you don't mind taking a second and letting us know, I'm going to share the question right now. What tools are you using for creating end applications? So this is a multiple choice question. I know that there's many teams that possibly use multiple tools, so feel free to check off all that apply to you. Just open up the live Q&A. We got some questions that are, I think, for both Joe and for Gilad. So I'm gonna start off with just asking a more general question. I think this is a really common question that we hear on our sessions. It's kind of about scaling. So and Joe or Gilad, whoever wants to take this can go ahead, but what do you feel like breaks first when you move the system from, let's say, like 10 users to 10,000 users? And how have you engineered around that bottleneck? I think the question of scale, even when it comes to open source, is very applicable here. So do you want to go first, Gilad?
Sure. So I think several things can happen. One is that obviously the resources, you need to see that something is scalable in terms of the Kubernetes cluster itself. This is often a challenge, or you didn't even account for the costs around that. The other thing is that you would see that you need to monitor everything. So if you don't monitor and you start getting a lot more users, things start to break because there are a lot of different other use cases happening, which you didn't account for at the end. And you can see that overall operationally, it becomes much more difficult, I would say, when you go from the lower end to the higher end. So you need to think about how do you scale that a system that allows you to move to more and more nodes and not just have everything on a single node, because that's usually how things, if you build it in a naive way, would happen. As I mentioned earlier, cost, and you need to account for it. And third, I think it's monitoring. I don't know if there are any other things that come to mind for you, Joe.
I think, yeah, obviously one of the main things is the computation and distribution and so on. From my Vizro hat on, when you say scaling from 10 to 10,000 users or any number of users, there's actually kind of two levels of users in Vizro. There's the developer users who are building the dashboard, and then there are the end users, the business end users who are viewing the output. And there's different problems for each of those different groups when you scale. When you're scaling developers, many developers on the same project, you need ways of allowing them to collaborate together. And that can be tricky in certain tools. One of the things that people typically tend to use is obviously Git. And so any tool that allows Git usage in the actual creation of the tool is much easier to scale at that point. And then in terms of end users, obviously the more users who are hitting a server, the more computational resources you need and so on. There's a very interesting tool called PyCafe, which allows you to run Python applications in the web browser. Effectively, you're then using the user's web browser resources to run dashboards, and that can scale infinitely across everyone on the planet who has a machine. that's a really interesting piece of technology that allows more scaling for almost an infinite number of users.
That makes sense. Thank you both. Joe, I think this is more for you. How does the system handle versioning across models, prompts, data sets, and dashboards simultaneously? So I think maybe it has to do with like editing it, maybe like editing the code and how that's visually represented on the dashboard, maybe. I think that's the...
Yeah, I'm guessing that, in MLRun, that's part of what we provide there, that so maybe it's easier to answer in that aspect, because for the prompts, what we've seen, we went through it relatively quickly, but there is actually a prompt artifact. So if you have different prompts and you're trying different prompts, it's a very common scenario that you have different prompts, is that you will want to try different things and you want to see the results of those tests, and then you like to go back. So let's say 10 prompts ago, something was better than the prompt I have now. I'd like to be able to use that. So the fact that everything is tracked allows you to do all that versioning. And let's say you're happy with something, obviously you would store it in Git and then continue on, and you still have those results stored in the repository and your code in Git.
Okay, thank you. And there were two questions here I see that were asked, if I'm not mistaken, during your demo, Gilad. What IDE do you recommend, and which extension and packages do you use?
I think it's very individual at the end. Personally, I use usually VS Code, but a lot of developers use PyCharm. We have seen Jupyter, which is usually just useful just for demos, relatively. But it really depends on the individual needs. I don't think there is one set of things, and whatever I say now in terms of extensions and things like that will probably change very quickly. So I don't think that's very easy to answer at the moment. Obviously, what we've seen that Joe has presented, there are usually a lot of extensions around chatbots and things like that, and LLMs. That's usually things that are very useful when running through the IDE itself.
Okay, thanks. Was there anything you wanted to add there, Joe?
Only just to echo, yeah, the IDEs can be quite a personal choice. And it also depends on whether you're looking to have Gen AI integration, kind of agentic flow integration. There are many options on the market right now. And some of them are for more kind of technical users, some of them are for less technical users. So again, it depends upon the level of technical comfortableness of the user.
Okay. And you both showed different repos. So I think that this question is just a general one of, to what extent are these repos available to test? So you mentioned the open source element, but how open source is it?
So yeah, they're both open source, and also MLRun and Vizro are open source, and they have Apache license. So the easiest way to test it in MLRun is to go to MLRun Community Edition. We recently updated the documentation based on feedback that some things for installation weren't clear. So hopefully now it's going to be easier. Obviously, if you're running on Kubernetes, it requires some resources, but if you're going to run with OpenAI or something like that, then you need the API key for OpenAI, and that should work. I don't think the Visual dashboard itself are very resource heavy. Actually, they're one of the easiest things to run in terms of computation resources.
And the same for Vizro. All of the Vizro code is open source. If you go to the repo link that's in the chat, you'll be able to find your way to everything, including the skills. And there's also the code that we demoed here for the call center is also available in the open source space. If you link through to that as well.
Fantastic. So this wasn't just informative, but also you guys can, go ahead and test it yourself. And of course, we're always happy to hear if you have any questions or need any help. There's a really great question here that I think is also something we've touched upon in previous sessions, and you touched upon it about the guardrails. So if you can speak to the question of testing the correctness of your application, how do you know that your banking application is giving correct answers and not giving answers potentially causing security breaches and releasing sensitive internal data? How can you guarantee that your banking application won't release passwords or internal corporate funds, transfer accounts, especially to knowledgeable hackers?
Yeah, that's a very good question. So there are several aspects here. One is that we've shown just very few guardrails. Obviously, you would want to have a lot more guardrails in the system itself. The other thing is to ensure that the prompt is actually better, and of course, you need to test it internally. Another thing that a lot of organizations do is actually not go directly to say, okay, here is a chatbot that communicates with the end customer, but actually think of an internal use case. So let's say that you have, rather than going for a banking chatbot, think about the first use case where you have a call center, and the call center, this is internal. So if I'm using Gen AI there internally, and maybe I'd like to add some internal chatbot that I'm using, doesn't matter if after the fact to analyze it or during the call to allow the agent to communicate with them, that's an internal thing. And let's say it hallucinates or returns things that it shouldn't, you can identify it. The other aspect that is important, and we've seen here, is that I'm heavily monitoring everything. So it's not just guardrails in real time, but actually applying a lot of monitoring. LLM as a judge is a very useful solution there. Obviously, there are other ways to monitor and a lot of other products that monitor things. The idea is that you want to connect to any type of monitoring system that you believe in, and as part of your tests, obviously see that. And in production, continue to test this because it's important, obviously, to identify all of these. So there's no way to reduce this risk to zero, but you can certainly reduce it significantly using these approaches.
And before I let you go, I really just wanted quickly to invite you all to explore our website at iguazio.com, where you'll find past webinar sessions, along with a wealth of additional resources, blogs, case studies, best practices, and videos. And I can't end the session without saying a huge thank you to Joe and Gilad for your excellent presentations. And of course, a heartfelt thank you to all of you for taking the energy and time out of your busy days to join our session. So really thank you, everyone. And I hope you have a great day and look forward to seeing you on the next session.